Okay, here is an example on the topic of power. And instead of working with a boring example, I thought maybe a good practical example that I have dealt with in my research. So imagine I have a robot. I still don't know what it looks like, how big it is, what it's supposed to do. Well, I know what it's supposed to do, but I don't know much information about my robot. I want to design it. But the purpose of the robot is actually known. It is a neuro rehabilitation robot. So it is a robot that must assist patients who have had neuromuscular disease like stroke or spinal cord injury, practice movements with their upper extremities in an effort to regain some of their lost movement abilities. So it's a very common scenario. Usually a physical therapist deals with these exercises and assists patients, but robots being potentially more repeatable, they don't get tired, and potentially they are cheaper than trained experts, can replace this function. So how do I design it? I don't know much about this robot, but I know a few information that can help me as a starting point in my design process. So from observations in and talking to physical therapists, I know that movements are relatively slow. You don't want to yank a patient's arm. It becomes extremely painful and unsafe. So the movements are relatively slow, and the amount of forces that a therapist exerts on a patient's hand is usually small too, again for safety reasons. So I know that in any potential direction, I want to have roughly maybe 20 Newton force, that is 2 kilograms, or roughly 4 pounds. It's a decent amount of force that help move a limb, but it's not too forceful. We don't want to be maybe stronger than that in our robot design. And I also know that if I move in that direction, a healthy human movement in a normal, not super fast motion, the velocity is roughly maybe half a meter per second. So V and F. So I know these are the characteristics of movement at the interface between the patient and the robot. So patient's hand and the robot's end effector. So from there, I can calculate that power at this interface, the where the energy is exchanged between the robot and the human, power is F times V. So how fast the force is moving, that is 20 times half. Roughly I need 10 watts of power at my end effector. So that's very good, because now I know what kind of or what size of energy systems I'm dealing with. So I can go and have a rough idea of my motor selection. So assuming that a very rough efficiency of the robot has some internal friction and for accelerations that we didn't account for, although they are relatively small in slow motions. So that reduces the amount of force that can be provided at the output. So a very rough assumption, I don't even know, but let's get my efficiency of the robot is half. And from there, I can find power of my motors input to my robot should be 10 divided by half, roughly 20 watts. And that is the good thing about power and energy, is that they add up. So it would be possible that a combination of motors, motor 1 and 3 and 4, work together to generate that amount of power. But I know roughly that my motors for this robot should have about 20 watts of power. So each motor is at the maximum, maybe I need a 20 watt motor, which are leads me to think that I need roughly a relatively small motor. So in comparison, for instance, the motors on electric bikes are in the order of hundreds of watts. So I need a much smaller motor than an electric bike. I was surprised to learn that many of these drone motors, new brushless DC motors, they're actually quite powerful, in the order of, again, hundreds of watts at a very compact form factor. So potentially I can think in drone motor space and find a small drone motor with roughly 20-ish watt. So there you have it. That is my back of an envelope, super rough calculations, but that gives me an idea that what kind of system I'm dealing with by just looking at the output power and relating that to my motor powers or input power to my robot. So that is the example. I will leave it here and we continue more in class.